Hi everyone, this is for week 11 explanation. Um, so before going to the week 11, you need to remember these some of the common rules of inferences before answering the questions. Okay, so these are all the theory questions. Theory questions we are not discussing, and this one is which of the following are tautologies means you need to check whether this is true for all values of p and q. So you need to go through this one by using the truth tables. Okay, so take p and q. P and q implies p r q means take p and q values. Okay, so p and q, take the values of both the p and q as, so you are having 0 0 0 1 like that values, so 0 0 0 1 1 0 1 1 values, and what they had given p and q. Okay, then p r q. So what is p and q? 0 0 0 1. Okay, so implies p r q. Like that you need to check p and q implies p r q. Okay, you need to check by using the truth table values. If they are true, then you can say that those are the tautologies. Like that you need to check. So for the values, truth table, and find out the values. Okay, the same thing is that one. And while coming to the knowledge base means the given, whatever the given rules and facts all combined together are called the knowledge base. Okay, these is whenever we want to say entitlement refers to sentences that are necessary true when the kb is true. That is the requirement for a entitlement for any sentence to be kb. So if any sentence is entailed by the kb, then we need to say that if it is necessarily true when kb is true. And this entailment in proportional logic can be computed using the truth tables, whether it is entailed or not. Okay, and these are theory questions. Forward chaining is we will come from facts with goals to derive new facts. Okay, this is the forward chaining. It matches facts with rules to derive new facts. In backward chaining, we will go from the back side. That is, already we know the goal with rules to derive new goals. Here, forward chaining, we are matching facts and the given facts with the given rules to derive the new facts. Here, the goals with the rules to derive the new goals. That is the difference between the backward and forward chaining. Okay, so proportional logic and first order logic, KB is also in true sentences. KB can represent what the false in the domain. Okay, so this is, if a KB is true, if and if all the sentences in the KB are true, and if a KB is false, if at least one sentence in the KB is false, then we can say that KB is false. But it has to be true means all the sentences in KB should be true. Okay, now we will see some facts. You need to remember these common rules of inferences for answering the questions. So the first one is alpha implies beta. If we are having like this, if they had given alpha, then we can infer beta from that one. So if this is a rule, alpha implies beta is a rule. If you know the fact that alpha is true, then we can say that beta is also true. This is called as modus ponens. Okay, then we're having another not beta, then we can infer not alpha. Reverse. So this is the forward. So we are saying that if alpha is true, then beta is true. In the reverse, we can't say that if beta is true, we can't say that alpha is true. Okay, this is in the reverse. This is called as modus tollens. Not beta, then we can say not beta, not alpha. Okay, reverse. Next, if we are having alpha and beta, then we can write alpha and beta. This is called as conjunction. If both alpha and beta they had given as facts to you, then we can infer alpha and beta. Okay, and if they had given alpha, then you can write alpha or beta. This is called addition. We are adding one more. Then alpha and beta, if we are having both alpha and beta, then we can infer alpha and we can infer beta. Okay, this is called simplification. If alpha implies beta and beta implies gamma, then we can write alpha implies gamma. This is called as a hypothetical syllogism. Okay, and one more, alpha or beta, not alpha, then beta. You need to remember, you have to be don't confuse with all these rules. Alpha implies beta, alpha true, beta true, not beta, not alpha. Okay, here alpha, alpha or beta, not alpha, we can infer beta. This is called disjunction syllogism. Okay, if alpha implies beta and gamma implies gamma, then we can write alpha or gamma. And if we are having AND rule, then we can infer beta and gamma. Similarly, alpha implies beta and gamma implies delta, and not beta or not delta, then we can infer not alpha or not delta. This is disjunctive dilemma. Okay, these 9 rules you need to remember for answering the questions. Okay, so this is called one more we are having called as rule of substitution. So you need to remember this one also. If we are having alpha implies beta, this is equal to not alpha or beta. Okay, if you want to change anything in the solving, if alpha implies beta can be written as not alpha or beta. If you're having not alpha or beta, you can write that with alpha implies beta. This is main important, you need to remember alpha implies beta. If you want to write in the another way, that is not alpha and beta. This is called as rule of substitution. Okay, and first we'll see about the forward reasoning. Okay, forward reasoning means from facts to goals. Pick a rule with matching facts and add the consequent to the KB till the goal is added to the KB. That is the forward reasoning. This is called data driven chain of inferences, and we'll see one example. Okay, before that one we're having two first order logic rules of inferences. If you see, this is called universal instantiation and this is called generalization. If we have having this one, for every x p of x means for every x there is a p of x, so we can substitute another variable. As in place of x we can substitute any variable a b c like that. This is called universal. If they had given p of a, then meaning that there exists a x such that p of x, this is called generalization. So if you say for example, there exists for every x, man of x implies mortal of x, meaning that in place of x we can replace with another one name, that is called universal, any name. If they had given like this, man of Socrates implies man of Socrates, means there is a person, there exists an x. This is called generalization. Okay, and we'll see one example for this one. Okay, so what they had given in the forward chaining, these are the sentences they had given. Alice likes mathematics and she likes stories. If she likes, so we'll come by sentence. Alice likes mathematics and she likes stories. So whenever we are writing in the alphabetical, you can take any alphabetical, we would take it as P. Alice likes mathematics. So first one, Alice likes mathematics, this sentence taken it as P. Then she likes stories, so Alice likes stories as Q. She likes mathematics, and so if she likes mathematics, she likes algebra. Okay, so mathematics and one more another thing added. First she likes mathematics, she likes stories, and another is algebra. Okay, so R, we took R as likes algebra. Then she likes algebra and likes physics. So yes is likes like physics. We'll go to college. Alice go to college as T. She doesn't like stories or she likes physics. So physics also already we done. Okay, so no need. She doesn't like chemistry and history. So for chemistry we took U, and for history we took it as V. Okay, so for every sentence we took it as a symbol. Then we will write the facts, whatever the facts they have given. So Alice likes mathematics and she likes stories. So mathematics means P, stories means Q. So and means P and Q. She likes mathematics and she likes stories. Next one, if she likes mathematics, she likes algebra. So if she likes mathematics, then she likes algebra. Algebra is R. So if she likes mathematics, then she likes algebra, means we need to write like this. P implies Q. Sorry, P implies R. When she likes mathematics, she likes algebra. Third sentence, if she likes algebra and she likes physics. Algebra is R, physics is yes. She likes algebra and physics. Algebra and physics, she will go to college. T. So implies T. Next, she doesn't like stories or she likes physics. Doesn't like stories, not Q. Or she likes physics. Likes physics is yes. She doesn't like chemistry and history. Doesn't like chemistry means not you, and history not we. So these are the given facts. Like this we need to write the facts. If means you need to remember that we need to write like implies. Remaining and are. Okay. So if the above sentence is true, it is necessarily true that allies will goes to the college. We need to check whether the if all these sentences are true, our goal is they asked us that whether allies will go to college. Will go to college is T. Whether that is T is true. They're asking. We need to solve this by using the forward reasoning. These are the given facts, and we need to check whether the T is true or not by using the forward chaining. Okay. So this is P and Q. They had given first. We wrote all these 1, 2, 3, 4, 5. So first P and Q, P and Q, P implies R. Okay, so not Q, not S first. So whenever we are doing P and Q, so go back to our rules first. I told you to remember the 9 rules. Okay, so P and Q, we can write P separately and Q separately. Okay, from first one. If we are having P and Q, then we can write P and Q. Then so if you see next from the second and fifth one. So what we're having in the fifth one? P. P is true. If P is true, then we're having R is true by using the modest one. So R is true by using the second and fifth. These are the two we're having, second and fifth. From the second and fifth, we got it as R. Next, from 4 and 6. So if we see 4 and 6, I told that if we are having not QRS, QRS, not Q. If it is true, then yes. So already it is not Q. They had given Q. So then S is true by using the distance resolution. Okay. Then what we are having R, S. Both are true. Okay. Then we can write by using the conjunction that R and S. If R and S is true, then T is true by using modest bonus. So now T is true. So we solve that the goal is reached. So the given example in the means that this allies will go to the college. Like that we need to solve. So for this one you need to remember that 9 rules, and you need to able to write the sentences in this form. But in an exam directly sometimes they will give these facts directly to you. Okay. This is a forward chaining. So in the that is one more we are having the backward chaining. Backward means we move from the goal to be towards the sub goals by using the facts. Okay. So if you see goal directed, this is go backward reasoning is a goal directed. We only look for rules for which the consequent matches the goal to the sub goals. The same example we'll take it as. Okay. So the given facts are these are the given facts. Okay. Is P is true. First, P and Q. So we wrote P, Q separately. P implies R and S implies T. So I told that no, we can have the this one Q implies S means P implies Q, not P R. So we wrote this one by using that one. Okay, not Q and S, we can write it as Q implies S. Okay, next not U and not V. Separately we wrote not U and okay. So what is our goal? T is true or not. Okay, this is our goal. Whether T, we wrote this as a goal set. How can we get the P? You see in the fourth group, from the fourth, if we want to get P as true, both R and S has to be. Okay, these are the two subgoals. So we are writing like this. R, comma, S means this is the first goal and this is the second goal. Both has to be true. So that's why we wrote R and S from 4. Okay, first we will see the first goal, R. Where can we are having R? If you see in the from the fourth, we can get the R from the P. So we replace R with the P. Okay, so with the P and S as it is from the 3. Next, if you see P is there in the first one. Okay, P is true. It matches with 1. So we reach the first goal. The next second goal we are having only yes alone. Where can we get yes? If we see from the fifth, we can get it from Q. Is Q is there? Q matches with the second one. So we reach that empty. So we reach the goal. So T is true. This is the backward. Forward is that one. This is the backward. We are going from the goal and sub goals, and we can see whether the sub goals are reaching, and if we get the empty goal, then we can say that our the goal is true. Okay, this is called the backward. Okay, now we are having one more concept called goal trees. Okay, so if you see an example, consider the knowledge base. Okay, nice toy of we are having two rules. If green of x, circle of x, we can get nice toy of x. Red of x, square of x, we can get nice toy of x. And these are the given facts. Two rules and some facts are. First, we'll write the goal tree. Okay, so if you want to write the goal tree, first what we're having goal? We're having goal is our nice toy of jet. Okay, nice toy of jet. How can we get that? Whatever it may be the variable, by using the rule 1 and rule 2, we can get nice toy. Okay, so either we can go for the rule 1 or rule 2. So we have our operation here by using rule 1 or rule 2. Either we can go for the rule 1 or rule 2. So how those are the sub goals. How can we get the rule 1? Green of x and circle of x. So we are having and operation here. And operation here, that is green x, circle x. So green x and circle x. Okay. For rule 2, red x, square x. And operation red x, circle x. Okay, so what they had given, green A, green B, we'll write that one green. This is the green A, green B they had given, and circle C, I'm not writing entire thing, red C, red D, red C, red D, square D, I think this is square, this is square D, and circle E, these are the given things. Okay, so what they had given, goal set is nice toy of x. Nice toy of x means, first we'll see for the rule 1. R means we can go in any direction. First we'll go for the rule 1. First we need to check the green x and circle x. What we're having, first one is green x and green A. So if we say A, then it has to be circle also. If it is x with replaced with A, then nice toy of A means it has to be both green A, circle A. Green A we are having, and we'll go and check under condition. We are not having green B here, circle A here, so it is failed. Next, it will check with the another circle. So we are not having any next green B, we are not having the circle B, it is also failed. Next, rule 1 is failed, R condition is there, it will go and check with the rule 2. This is doing by using the depth first search algorithm like this. Okay, so it has to be true means nice toy of x means it has to be both red and square. First it will see C, red C. It will go and check whether square C is there or not. No, we are not having square C, so it will fail. Next, red D. So it has to be check whether square D is there or not. Square D is there, so it is success. Okay, so success. This is the another by using the goal tree we can check whether it is true or not from the given. Okay, now we will see our assignment questions. First we will see if this is the 11th one. In the KB, ABC denotes constants and the topper champion admission denotes the unary predicates and X is a variable. Select the sentences that these are the sentences they had given to us, and they are asking select the sentences that are entailed by the KB. So we told that, so if consider this as P or Q implies yes, like this. Okay, so if this is true and this is true, both are true, then we can say that this is true. Okay, so what they had given, admission of A means this is true. Admission of A, and what they had given, topper of B, and one more thing they had given, not admission of C. Okay, so from this one they had given topper of X or champion of X. Anything is okay. Then we can get that. We can get if it is a topper or champion, then we can get the admission. So they had given topper of B. So this condition is satisfied. Then we can say that we got the admission. So admission of B is correct. Okay. Next they had given topper of B. So we got admission of B. Topper of A, we are not having any clues here to get the topper of A. So we are not having that choice. Next, not champion of C. So if you see, if you remember, P implies Q means not Q, not P. So by using that condition, not admission of C they had given. Not admission of means if C is not getting admission, so these two, either one may be true. Either it is not topper of X, not champion of X. So that's why this is also true. Okay. And next, for every X champion of X, so if it is a champion, then admission is getting. Okay. So these are the three choices. You need to remember the rules. Always the rules will be useful for you. Always. If this is true or this is true, then this is true. If this is false, then any of these two are false. So we are replacing these constants with this variable X. Okay, so if X is admission of A means these two are true, like that. Okay, say here also. So we are replacing this. So if you see each option contains a pair of formulas, which of these are pair of unifiable? Unifiable means X X. So what we are doing here, likes X and comma X, likes joy, and the meaning that we are saying that X replaced with the joy. Any constant can be replaced with so any variable can be replaced with a constant, any variable can be replaced with a variable. These are the unifiable. Okay, so here variable X is replaced with a constant is true. Here variable is replaced with another variable, is also a true. And if you say game, so here constant is replaced with the variable, so this is false. We can't replace the constant with a variable. If we are having a constant, we can replace with a variable. And uh, variable with a constant, variable with a another variable. This is false. We can't replace constant with a variable. And here also, if you see travel Joe X Y. We are replacing Joe with U, X with Ami, Y with. So Joe with U, Y, Y. Y, Y means it has to be both same. Ami and Joe. Different names they had given. So we have to replace with the same name. That's why this is not true. Remaining all are true. Okay. Next. While coming to the group 2, this is our given KB and these are the facts, 5 rules and these are the facts. First they ask let the forward chaining algorithm run to completion. For each rule in the KB, count the number of times that the rule generated a new fact. Okay, so how many times that rule is used to generate a new fact? That number of times you are using that rule, we have to be right here. Okay, so whenever we are doing forward chaining for that one, these are the these are the 5 were list out 5, 6, 7, 8, 9, 10, 11. We wrote all these 11. Okay, now if you see what we are having in the rule 1, B of xy implies P of xy. So we are having B of kt. Okay, if B of kt, then we can write P of kt by using the rule 1. Next we are having by using the rule 3 from 10 and 11. S of A, W of D. So if you see S of A, W of D implies C of S of X and W of Y, C of XY. So how can we write C of A, D? Okay, we applied the rule 3. Next, if you see rule 4, S of X, R of Y. S of X, R of Y. Okay, next we got P of T. Next, using the rule 5 from 14 and 13. 14 and 13, that is P, T, A, C, A, D. So what we will get? M, T, D. Next, again by using the rule 5 from 14 and 7, this one, P, N, A and M, T, D, we got it as M, N, D. Okay, now you see how many times we applied the rules. Rule 1 one time, rule 3 one time, rule 4 one time, rule 5 two times. Okay, this is for so 1 0 1 1 2. We didn't apply anywhere rule 2 in solving, so we are not having h of x y. We are not having any facts here by using h of x y to apply rule 2. Okay, so these are number of times we got. Rule 1 is 1, rule 2 0, rule 3 1, rule 4 1, rule 5 2 times. Forward chain. Okay, let the forward chaining algorithm run to completion. Which of the following facts will be added to the KB? So what are the thing added? P of kt is added, and AT is not there. AT is not there. C of AD is there. C of AD is there, and M of DN is not there. ND is there, not DN. You should be very careful here. You see XY, XY, YZ. Then we will get XZ. You should be very careful about these constants, whatever we are using inside. Okay, next we are having M of TD. M of TD is okay. Next, M of UV be the goal, where U and B are the variables. Generate the complete goal tree. Count the number of instances of each rule 1 and 5 that occur in the goal tree. Okay, here so many options done there. Actually, whenever we're using the goal tree, whatever we constructed there, and they didn't mention anything about that one, whether it is true or false. That's why you got so many options here. If you see, we can use here also, instead of goal tree, you can use either forward chaining or backward chaining. If you see forward chaining, what we got here, one number, rule 1 is 1 times, rule 2 is 0, 1 1 2 times. So that's why they had given the same answer also for this one also. They didn't mention anything about anything. We can use either forward chaining, backward chaining, or goal tree. So that's why they had given this also example. Okay, so if you see backward, we'll get only this option. So if you go for the goal tree, if you construct the tree, then we can get this answer. Because if you say M of UV, this is the goal. This M of UV you can get in two ways, by using the rule 5 or by using the rule 2. So there we are applying rule 2 also. So if you want to draw the goal tree here, for that one, M of UV. So M of UV we are getting either by rule 2 or rule 5. So here we are using rule 2. Whether the constants are true or not, we are not doing that one. Just we are applying rule 2. That's why we can also count rule 2 also. That's why they had given rule 2 also into consideration. You can better you can do this one, no problem. If they are asked if they are asked us to by using the uh, tree, under tree, then follow this under tree. M and Q we can get by using both rule 5 or rule 2. So that's why or rule 2 or rule 5. Then rule 5 we can get again having two sub goals, P and C, and that's why you wrote P and C, and rule 5 we applied. Again this P, this sub goal, how can we reach? This P we can reach by using this S and R. So S and R, and so if you see P can be applied by using the rule 1 also. Rule 1 also we can get rule 4. So that's why R operation is there. Rule 1 or rule 4. So rule 1, rule 4 means again we are having S and R. So S and R. Again we are having this third one, C by S and W. We are having only one option for getting the C, that is only 3. Rule 3 S and. Now if you see what are the rules we applied, 1, 2, 3, 4, 5, all rules we applied here. So that's why they had given option here, this one also, 1, 1, 1, 1 also. Okay. So anything okay, but better follow this. You read the question very carefully whenever they are asking this type of questions. So let MU be the goal, where U and where the variables. Generate the complete tree. Count the number of instances of each rule that occur in the goal tree. They didn't that occur. They mentioned. They didn't that matches. They didn't tell that, whether it is matches with the U and V same variables or not. Just that occur in the goal tree. That's why you can give this answer 1, 1, 1 also. Okay. So this is about the week 11. Thank you.